Hi folks, we're going to take a look at 15A from part A of the Unit 3 assignment. So here they want us to find this unknown k value such that this function will have critical points. Okay, so we notice here that we've got a rational function, so we expect the critical points to occur where the first derivative is equal to 0. Okay, so this is one of these cases where you might not know where this is going, but just do what would be natural to do. If you're looking for critical points, find the first derivative and see where it's equal to 0. And then from there, we'll see if we can figure out how to solve this problem. So start by finding the derivative here. Okay, so derivative of the numerator is just 2 times the denominator function, x squared minus k squared. Okay, minus the numerator function, 2x plus 4, times the derivative of the denominator function, which is just going to be 2x, since k squared is just a constant. Okay, and this is all over x squared minus k squared squared. All right, so let's determine where this is equal to 0. So what would we normally do? We would just simplify the numerator and see what would have to happen in order to solve it. Okay, so again, won't ask questions. I'll just go along. So let's distribute. We have 2x squared minus 2k squared. Okay, and then here we've got minus 4x squared. All right, and here we have minus 8x. Okay, let's keep going here. So we got 2x squared minus 4x squared, so negative 2x squared, and then minus 8x, and then minus 2k squared. All right. And of course, in order for a fraction to be equal to 0, it's the numerator that needs to be equal to 0. So that means that negative 2x squared minus 8x minus 2k squared has to be equal to 0. In fact, let's simplify this a little. I can divide both sides by negative 2 to simplify my life. So that means I've got x squared. So negative 8 divided by negative 2 plus 4x. And this is going to be plus k squared is equal to 0. Okay, so this is the expression that has to be equal to 0. But this is where I notice that I've got a quadratic equation here. All right, so we've got a quadratic expression equal to 0, and this is where I want you to think back. What needs to happen in order for this to actually have solutions? All right, and if you think about how we solve these equations, you remember that, of course, that's just given by the quadratic formula. And in order for x to actually exist, you need this expression inside the square root to be positive or 0. Okay, because if this expression inside the square root is negative, well, you can't take the square root of a negative number, so there's no solutions. So in order for this equation, to have a solution, we need our b squared minus 4ac to be greater than or equal to 0. Okay, this is what we have to establish. And hopefully from there, we can determine what k values will help satisfy this. So let's write this out. So b squared, so 4 squared is 16, minus 4 times 1 times our c is just our k squared. Okay, and that has to be greater than or equal to 0. So we have 16 minus 4k squared greater than or equal to 0. Can simplify our lives here by dividing both sides by 4. As long as we're dividing by positive 4, the inequality won't change. So we've got 4 minus k squared has to be greater than or equal to 0. Okay, so any k values which satisfy this inequality will give us x-intercepts of the first derivative, in other words, critical points. All right, so how do we solve this? Well, think of this again as a quadratic expression. Okay, 4 minus k squared, what does that look like on a graph? Well, I can just graph this as a function. Negative 2 and 2 are going to be my 2x intercepts, because if I factor this, I'll have 2 plus k, 2 minus k. And so here I see that this expression is going to be greater than or equal to 0 when k is between negative 2 and positive 2. So k has to be greater than or equal to negative 2, but less than or equal to 2. All right, and there we have our solution. These are the k values which are going to allow this equation to have solutions, which is what's going to make the first derivative equal to 0. In other words, giving me critical points. Okay, I guess there's one little thing you do have to be careful of is obviously x can't be equal to I guess plus or minus k. So whatever the k value is, obviously x can't be equal to that there. Okay, but there's our solution. Okay, so let's recap. We needed to determine the k value such that this has critical points. So what condition has to be met? The first derivative needs to be equal to 0. But it turned out that we ended up with a quadratic equation which needed to be satisfied, and a quadratic equation has solutions when the discriminant, my b squared minus 4ac, is greater than or equal to 0. And from there, I was able to figure out my solutions. Okay, that's it for this one.